Year 10. So this is our next lesson looking at extraction of metals. So these first two questions for you to start off with are looking back at what we looked at last lesson on mining and smelting. So 2 explain questions for you to have a go at, and then if you can submit these in an assignment that I have set up on Microsoft Teams so that I can have a read of your answers. So if you pause the video whilst you have a go at that. So today we're going to be looking at 2 methods which we can use to extract copper, and specifically these methods are used in order to extract low-grade copper. So I'd like you to be considering what the difference is between high-grade and low-grade copper ore. So pause the video whilst you have a think. So the difference is the amount of copper that is in that copper ore. So high-grade copper ore contains a lot more copper than this low-grade copper ore. But the methods that we are looking at extracting, these target these low-grade ores. And so these have little amounts of copper. It's not worthwhile doing mining and smelting. The requirements are too high for the little amount that we would get from it. So the 2 methods we're going to be looking at is bioleaching and phytomining. So to start with, I want us to consider how these words are made up. So bio, which you might be familiar with from biology. So biology is the study of living organisms, and that is where that bio comes in. So bio is for living organisms. Leaching, you might have heard of leeches before, but they drain away. So bioleaching is using living organisms to drain away the metal compounds. Whereas phyto, this prefix here, this uses a different living organism of plants. So in bioleaching, the living organism that we use is bacteria, whereas phytomining uses plants. And we've looked at mining last lesson, and that was extraction from the ground. So both of these are biological methods, and that means that they are quite easy to do because it's living organisms that are doing the work for us. And these biological methods are better for the environment because they're using those living organisms, instead of having to apply high energy treatments such as in smelting. What I'd now like you to do is looking at bioleaching in more detail. So there are 2 YouTube videos for you to watch, and this is the summary about bioleaching. So it will make more sense once you have watched the video, so you might want to pause this video, watch those, and then come back to this explanation. So our bacteria, these are living organisms, so that bio part of bioleaching, they absorb the copper compounds. So these copper compounds is the low-grade ores that have been found in the ground, that have been left behind perhaps after some mining has happened. And we do this in order to produce leachates. Now, leachates describes an acidic solution which is then containing those copper compounds. Now, a disadvantage of this is that it's a very slow process, so it takes a while for the bacteria to absorb those copper compounds and to produce those leachates. But we do manage to actually produce 20% of our copper this way, so very advantageous to be able to extract significant amounts from low-grade ores, where there's not really much copper there, but significant amounts of copper are produced by this method, where it would take a lot of energy and resources to otherwise extract that low-grade ore. A negative of this, though, is that it produces toxic substances. So toxic obviously means it's harmful to you, it can kill you. And so we want to be thinking carefully about where those leachates end up going, so that we're not harming any environment and animals that might be living in those areas. So the next thing to consider is phytomining. So this is how plants are used in order to extract the copper compounds from the soil. So here you can see in this diagram, we've got our copper compounds, those orange circles here. And what our plants do is they absorb or take up those copper compounds through their roots from the soil. So those copper compounds are taken out of the soil and into the root. What we then do is we burn the plants, which leaves behind an ash, and in that ash we then have those original copper compounds. So this phytomining process, the benefits of this is actually how we get it from the soil to the copper compounds that are in the ash. But we do need to do further processing on these compounds. Electrolysis we're going to cover in a separate lesson, but ion displacement reactions we will have come across before. So iron is more reactive than copper, and so it can be used in a displacement reaction where we're reacting our elemental iron with our copper ions that are in those compounds in order to extract our solid copper and then leave behind those iron ions. So this is our ionic equation for that ion displacement reaction. So advantages of this, again, it's very easy, simple to do because we're using plants to do this job for us, for what would otherwise be very time consuming and very requiring a lot of resources in order for us to do this an alternative way. It is, however, still a slow process because obviously we have to wait for the plants to grow and absorb these copper compounds. But once the plants have grown and absorbed the copper compounds, that burning process and the further processing, this is going to be much faster. So what I'd like you to do is, considering everything that we've discussed through that summary of bioleaching and phytomining, the videos that you've looked at, consider what the advantages and disadvantages are for each of these processes. So if you pause the video whilst you have a go at this, I've put the answers on the next slide, but do have a go at this yourself first. So we've spoken about most of these. Main thing we may have not talked about is about our plants producing greenhouse gases when we burn things. And equally, we haven't talked about the fact that it's cleaning up contaminated land. So where these low-grade copper ores are found, we have contaminated the land with those compounds that might have been left behind from mining, etc. But both of these are typically low energy cost because we're using other organisms to do the job for us. And so both of these are quite environmentally friendly. Bioleaching more environmentally friendly because they don't produce those greenhouse gases, but they are producing some toxic chemicals, so we need to be careful about where those toxic chemicals end up. So your next activity and final activities is to create some storyboards. So on Grow for Schools there is both the images that you can see there, but also I've done a template for you with the text ordering these processes, and then what you need to do is order these 12 images. So there are 9 for phytomining and 5 for bioleaching. Note that the first and last image is common in both of those processes. So, because you may have already worked out 9 plus 5 does not equal 12. So our first and last images are the same, so you only need to use those 12. And then through drawing arrows from these text boxes to the relevant pictures, so that you can help narrate this storyboard. And then you'll notice each of them have 2 questions for you to be answering. Okay, so checklist for today's lesson. Once you have done your storyboard, this is everything that you should have done from this lesson. So have a read through, make sure you've got a complete set of notes. Importantly as well, make sure you've uploaded your starter onto Teams so that I can have a look through it. And of course, getting to the end of making those storyboards, but also answering those questions. If you do have any trouble with this, please do send me an email. Our next lesson will be a live lesson tomorrow, so we can also talk about any questions that you've had then. But it would be helpful to know in advance so that we can collate those questions together. Thank you all for watching and see you all tomorrow. Thank you.